Okay, let's dive into one of the most incredible concepts in the entire world of AI. It's called zero-shot learning. And yeah, it sounds like something straight out of science fiction, but it's very real. And it's giving machines a mind-blowing ability to recognize things they've literally never seen before.
Just think about this for a second. If I showed you a pen, even some weird, futuristic pen you've never encountered, you know exactly what it is, right? Instantly. You can do that because your brain generalizes from its basic features. The shape, the tip, the fact that it's used for writing. But how on earth do you teach a computer to make that same intuitive leap?
You know that simple little act of generalization we just talked about? Well, for an AI, trying to replicate that is a monumental challenge. I mean, the sheer scale of what our brains do without even thinking about it is just staggering.
30,000. That's roughly the number of different object categories a human being can recognize. Now, trying to get an AI to do that using the old-school methods, well, that would take an amount of data and work that's almost hard to even imagine.
See, the traditional way, which is called supervised learning, is a total grind. To teach an AI what a cat is, you have to feed it thousands and thousands of pictures, all meticulously labeled cat. Now, just imagine doing that for 30,000 different things. The time, the money, the sheer amount of data you'd need is insane. This is the exact problem that zero-shot learning was created to solve.
So, how does an AI learn to see something brand new? It's not magic, I promise. It's all about getting the machine to understand the meaning behind a label, instead of just memorizing a bunch of pictures.
Okay, so there's your formal definition, a model that can make predictions about things it has never, ever been trained on. But to really get how this works, let's think about how a little kid learns about the world.
So imagine a child who's never actually seen a picture of a bird, but they've read about them in a story. When they finally go out into the yard and see a robin hopping around, they can correctly point and say bird, because it matches the description they learned. And that's the core idea right there, learning from a description of concepts, not just from a pile of labeled images.
So how does an AI actually build this kind of understanding? Well, one of the most intuitive ways is by breaking objects down into their core features, or what data scientists like to call attributes.
Okay, let's try to teach a model about animals, but we're not going to show it every animal in the world. Instead, first we teach it the concept of stripes by showing it a bunch of pictures of tigers and zebras. Now it gets what stripes look like.
Next up, we teach it the concept of yellow by showing it images of canaries. The model isn't really learning canary, you see, it's just learning the attribute yellow. And finally, we teach it the general category of flying insect by using pictures of flies. So now our model has 3 distinct attributes stored away in its knowledge base. It knows stripes, it knows yellow, and it knows what a flying insect is.
And here's the payoff. We can now show the model a picture of a bee, an animal it has never seen before in its life, and it can correctly figure out what it is. It's not magic, it's just combining the attributes it already learned. It sees stripes, it sees yellow, it sees a flying insect, and it puts them together. That's zero-shot learning in a nutshell.
But, this method has a weakness. A pretty big one, actually. It relies on this idea that you can neatly define everything with a simple checklist of features. And as we all know, the real world is, well, it's a lot messier than that. This right here illustrates the problem perfectly. You've got a Tesla Cybertruck and a Volkswagen Beetle. They are both, without a doubt, cars, but their attributes are almost complete opposites. An AI that's only relying on a simple checklist for what makes a car would probably just get very, very confused.
So to get around these kinds of issues, data scientists came up with some more advanced and, honestly, even more fascinating methods.
One of these advanced tricks is called embedding-based learning. Just imagine a giant, invisible map where every single concept has its own specific location. Dog is right next to cat and wolf, but it's really far away from car. This method plots both images and word descriptions onto this map. So when the AI sees something new, like a fox, it just plots it on the map and sees what its closest neighbors are. It's less of a checklist and more like a high-tech game of finding conceptual relatives.
Then there's another really powerful method, and this one's my favorite. It involves something called Generative Adversarial Networks, or GANs for short. And this is just wild. It uses 2 AIs that are trained together by playing a kind of game against each other.
So you have a generator, which is like a master art forger. It tries to create fake synthetic images of an unseen thing based only on a text description. And then you have a discriminator, which is like a detective, and its only job is to try and spot the fakes. The forger just keeps getting better and better by trying to fool the detective, and the detective gets better and better at spotting fakes. This just goes on and on until the forger's so good that its creations are basically indistinguishable from the real thing. The AI can then use these perfect synthetic examples to learn, just as if they were real labeled data. It's brilliant.
Okay, so this is all incredibly cool tech. But what's the bottom line? What does all this actually mean for the future of AI and for us? Because this isn't just some clever academic trick. It has really profound implications.
So why is this such a big deal? Well, first off, it makes developing AI way more efficient. It cuts down on that enormous time and cost of labeling data. It also makes AI systems much more flexible and scalable, so they can adapt to new ideas without having to start over from scratch. But really, the big thing is that it brings us one crucial step closer to the holy grail of AI, a machine that can truly generalize its knowledge, a lot more like a human does.
This really isn't just about identifying animals or cars anymore. It's about giving AI the power to reason about the unknown. And when you think about that, it just opens up an incredible world of possibilities for what intelligent systems can help us achieve in the future.